So I didn't understand any of that. Was he nice? That was good. Right. Hi, everyone. I'm Dave. Really excited to be here. And I'm going to be talking about effective code review. And I believe that effective code review reduces the overall cost of software development. And hopefully by the end of this, you will believe that as well. And you'll be convinced. So why is it that effective code review will reduce the overall cost? And we might have seen graphs like this before, that generally, the later on you find a bug, the more expensive it becomes. So we can find a bug really on in our software development process. Obviously, it's normally a lot cheaper to resolve that bug, and the costs associated with it are a lot less. So what we want to do is we want to take bugs from a potentially expensive time and kind of push it over there where it's much cheaper to fix. And code review is one of the ways in which we can do that. So that's why we're here. I'm Dave Liddament. I think he said most of that stuff. I help organise PHP Southwest and Bristol PHP training. When I'm not doing tech stuff, I scuba dive. That's me in a cave in France. I also do a bit of running. I've recently also just written my first bit of open source software, which is called SARB, which is Static Analysis Results Baseliner. So if you use advanced static analysis tools like SARM or PHP Stan, have a look at that. It'll help you with baselining. And you can find me on Twitter at Dave Liddament, so feel free to tweet anything nice. Okay, so the agenda for this, we've kind of discussed why. We're going to have a quick look now at code quality, then we'll look at what code review is, how we go about implementing it, some of the tips I have picked up as I've been going along. So I've been working for about 15 years in software development, and probably at least half of that time has been with projects that have used code review. And I would not go on projects without code review now. So, code review, though, doesn't stand on its own when it comes to code quality. There's a number of other things that it works really well with. The first thing is we need some kind of automated testing. It doesn't really matter what tools we use, whether it's PHP Unit or Behat or Codeception, but we need some level of automated testing. It's also really important that we have some form of static analysis of the code. Things like check style, which is there to make sure that our code adheres to whatever coding standards we have on our project. We might also want to use things like PHP code style fixer, so it automatically fixes stuff for us. And we might also want to look at some of the more advanced tools like SARM. But we need all of these tools there because they do a lot of the automation so that us as humans don't have to. And finally, we need some kind of continuous integration server, whether it's Jenkins or Circle CI or Travis. And that's there so that we write some code, we push it all up, it goes and runs all the tests, all of our static analysis tools, and then only when it's happy that do we then involve the humans for the code review element of it. So you can do code review on its own, but it's best done with all of these other tools. And anyone who's coming to the workshop tomorrow, we're going to learn how to set up GitHub and Circle CI for that. So I'll have a Wikipedia definition of code review. Code review is the systematic examination of source code, and it is intended to find mistakes overlooked in software development, so improving the overall quality of software. So that's a pretty good definition of it. So how's it done? I mean, there's a couple of ways. Sometimes people just work in teams, pair programming. So that's kind of real-time code review as people are working away. And a lot of what I'm saying will be relevant to that way of working. But today I'm sort of specializing a bit more in using something like, say, GitHub or some tool for code review. So somebody works on their code, they push it up, and then another developer looks at that code and comments on it. So that's kind of a really quick introduction about code quality and what it is. And now we're going to look at some of the benefits. And there's 5 main benefits that I'm going to talk about today. So probably if I asked you what you thought the main benefit of code review is, you'd probably say we're going to find defects. We're going to find things that are wrong with our code. And actually, I'm going to talk about two classifications of defects. The first is, I suppose, your traditional bugs. So that is code that if you executed, either the application would crash or the application would give you the wrong result. So you might expect in code review you're going to find lots of issues like this. But there's another classification of bugs called evolvability defects. And evolvability defects, its kind of formal definition, is code that makes the code base less compliant with standards, more error-prone, or more difficult to modify, extend, or understand. So it's a posh word for technical debt, basically. And the interesting thing is the proportion in which you might find these. So there's been a number of studies on code review, and they say that your traditional bugs, the things you might expect to find in code review, might only account for, say, 20% of the issues raised during code review. Oh, sorry. Yeah. Sorry about that. Is that better? Okay. Hopefully that's better. Nope. Sorry about this. Okay. Oh. Oh. Did you miss the first half? Should we go back? We want to go back. No. This is the important bit now. Right. So, the reason this is so important is if you started doing code review, you might think we're just going to find actual real bugs. But actually, a lot of what we're going to find are these evolvability defects. And evolvability defects are still pretty important because of the costs associated with them. So low evolvability costs money. Code full of technical debt has issues. So here are some links to some studies, and my final slide has all these studies in there, so you can go and look them up if you want. But they're saying new features on low evolvability code, this is code full of technical debt, might take 28% longer to implement. And fixing bugs takes 36% longer. So although we're looking at stuff which isn't fundamentally breaking our code, there is a huge cost associated with evolvability defects, which is why it's really important that we find them, and it's why it's really important that we go and correct them. And we've probably kind of seen this stuff before. If we imagine we've worked on a project, a long-running project, and we think how long it takes to make code of features of similar levels of code and complexity, and on some projects that kind of just ramps up. It starts off quite simple, and as time goes on, we've got more and more features. It just takes longer and longer to write essentially the same level of functionality. Whereas if we've got high evolvability code, that's code with not much technical debt, essentially our velocity is the same throughout, the green ones there. So this, I think, is a really important takeaway. The majority of issues we find in code review will not be like traditional bugs. This is okay. Yeah. So if you're there doing your code review, you're thinking, I'm not finding that many like actual bugs, but you're finding all these evolvability issues. That is fine. That's good. And so most of the comments will be, look, this is how we improve the code. But the lower the technical debt, the lower the overall costs. There is still a lot of business benefit in doing this, and there are studies to back this up. And the other important thing is make sure you're selling your correct metrics to management. So if you're saying we're going to introduce code review and we're going to find loads of defects, if you just report the actual bugs, that might only be 20% of that total number. So that's our first major benefit of code review, is we will find defects, both bugs and evolvability defects. Second one is it acts as a good point for security review. There's a lot of things that we cannot easily automate when it comes to security review. So a lot of these are embarrassing things that I've done wrong, and one of them was I was having some trouble with some authentication system. So just in development, I started logging sensitive data, like username and password. And that was fine in development because I was never going to push this code to live. But I forgot about the logging. I pushed it up. But fortunately, we had code review, and someone found it. And I thought, I'm probably the only one silly enough to make a mistake like that. I actually wrote this slide about a year ago. And about a week after I wrote this slide, I got an email from Twitter. And Twitter said they'd been logging sensitive information into logs. But apart from me and Twitter, I'm sure no one else makes those mistakes. But there is another way of looking at this. If you use tools that look at your logs and maybe they capture things like stack traces, actually some of those stack traces might have sensitive data in. So you've got to start looking. If you use tools like Bugsnag, you can tell them, say, look, if any of the fields are called password, then do not send this over HTTP in it. Just blank it out. So that's something where you might have to start looking at stuff and making sure that all that is configured correctly. And these are the things that can only really be done manually. Unlikely, but possibly somebody's GitHub account got compromised or their computer got compromised. And maybe somebody's tried to nefariously upload software that's not supposed to be there, maybe some malware. So if you're doing a code review and you see a file and you think, I'm not sure that's supposed to be there, do query that. The OWASP Top 10, have people heard of that? It's basically a whole series of issues that are commonly found in software. It's a whole subject area in itself, and I'd recommend that you Google the OWASP Top 10 cheat sheet, and it will tell you the kind of issues you find. And a lot of them are very difficult to find automatically in code review, so that's why they have to be manual inspection. And then there's things like where people might be doing things badly, like weakly hashing passwords or not hashing passwords at all. And again, if you see code like that, just pick it up in the code review. In fact, anything really to do with authentication or hashing, if people aren't using actual proper libraries, then they're probably doing it wrong. So security review is the second major benefit of doing code reviews. Another real benefit is spreading the knowledge. So what I found is I might be working on a bit of the project. I might be focusing just on this bit of the project, and my colleagues are looking at other stuff over here and here and here. And because I'm doing code review, I can see what they're doing there. So I'm just having a little idea of what's going on over there and over there. And possibly, I might see them doing something and say, oh, hang on a minute, I've written some code here that might be of use. Or they might be doing stuff and they see things I've done and they say, hang on a minute, Dave, we've kind of got a similar code down here. So spreading that knowledge is really, really good. And it also has the benefit that we're not working in silos. So we don't have a bit of the code that's Jane's code, a bit of the code that's Bob's code, and Jane doesn't want to touch Bob's code and vice versa. So we can get rid of this kind of stuff while everyone's got kind of complete ownership of the code, and they gain that understanding through doing code reviews of what other people are working on. And that's great, because that means when somebody wants to go on holiday, they don't have to worry about things. They know other people understand the code base well enough, and if something happens while they're on holiday, they can sort it out. Has anyone heard of the bus factor? So the bus factor is how many people have to get run over for your project or your company to fail. So if you have a bus factor of 1, that's one person has all the knowledge and they get run over, that's it. So the good thing about code reviews is it spreads that knowledge, so maybe you have a bus factor of 2, or hopefully more. So the fourth real benefit, and I've definitely seen this on projects, is kind of mentoring. So when you have potentially inexperienced people come along, they benefit in both ways. They benefit by doing code reviews, so they see what other people are doing. And I have learnt so much from reviewing colleagues' code. I can really understand lots of new things from that. But also, if they're relatively inexperienced, they get really quick feedback on the code that they're doing. So mentoring is quite good. And the reason, again, from a kind of benefits and kind of cost-benefit analysis is that generally the more experienced or skillful you are in something, the lower the rate that you introduce defects. And experience doesn't necessarily just mean time spent programming. It could be time spent on a particular project or working in a particular domain or just using a particular technology. So I've been writing PHP for maybe 10, 15 years, but I've never used the Zen framework. So somebody who's been using the Zen framework for a year, I was working on a project, they could have loads they could tell me, even though I might have been working in PHP for a lot longer. So experience, yeah, means many things. And the fifth benefit of code review is people modify their behavior when they're being watched. I think the biggest increase in quality happens when you introduce code review and people just believe that their peers will be looking at the code and might be commenting on it. And we've certainly had projects where we started off without code review and then we've introduced it, and it just feels like there's a big step change in the quality of code. Now, I don't have any statistics to back that up, but there was a similar study done on initially the UK police, but it was replicated around the world. And what they did was they put cameras on the police officers, and from one year to the next, there was something like a 90% reduction in the number of complaints. And that's not necessarily because the police were misbehaving, but everything was on camera and there was kind of evidence to back everything up, and people said, okay, we're going to start behaving a bit better. So just by having the police with cameras made a massive difference to that. And it's the same kind of concept, I think, with code review as well. So here are our big 5 benefits. We do reduce defects, although predominantly we're going to be reducing the evolvability defects. We could find things like security vulnerabilities. We're spreading the knowledge around the whole team. And again, mentoring, I suppose, kind of comes under that. And it's just peer pressure improves code quality. So this is why we're here. Effective code review reduces the overall cost of software development. And hopefully, I've shown you in the benefits, you can see how doing it well will reduce costs. So now we're going to look a bit more about how we actually go around implementing it. I think the most important thing, as alluded to earlier, is we want to automate everything we possibly can. So any task where we can analyze the code and say with pretty high confidence this is either good or bad is the task that we want to automate. So there's things like our tests, for example, our code style. So we shouldn't really be looking at code and saying, are the commas in the right place, are the opening and close braces in the correct place? That should be done by an automated tool, for example, PHP CS Fixer, or there's PHP CS. Linting as well, and it doesn't just have to be for PHP. There's tools to lint YAML, Twig, our doctrine, and even Composer. Make sure we do a Composer validate as part of our CI, just to make sure our Composer, JSON, and log files are in step with each other. We want to also drop in some more advanced static analysis tools. These do the kind of clever analysis that things like PHP Storm do for you. Also worth doing third-party security checks. So Sensio Labs have a security checker. And what that does is it looks at your Composer files and it works out if any of the packages you're using have got security vulnerabilities in them. So at an absolute basic, I'd have like most of these things in there. And it's only once all these automated tests pass that we then involve a human, because automated tasks are quick and cheap to do, whereas human time is pretty expensive. So we assume all these things passed. The first question I'd ask when I'm reviewing the code is, are the tests testing the required functionality? So often, it is much easier to read a test and say, I can see what that test is testing. And we know by this stage that the test has passed because our CI is running all our tests. And we know then that if our tests are passing and our tests are testing the right thing, we're probably okay. So I'm comparing what my tests are doing against the spec or against the story or against whatever Jira or Trello card we're doing. So like a really simple example, suppose we had something that was, creating slugs. So we give an input, and then the output all has to be lowercase, and any non-alpha numeric character is a dash. And I look at my test, and I can see, well, something doesn't look quite right. There's this hello Dave, and it's got a capital D. So what I'd probably do is I'd say, in code review, I think this test is wrong, and I'd pass that back, and then they would go off and fix it. They'd correct the test, and then see if the code works. So this is the most important thing, because if our tests are not aligned with our requirements, then they're kind of a waste of time. And generally, it's easier to understand tests than the code. Like, presumably, the implementation of this might be some difficult regular expression, which is very hard to manually look at and work out if that always works. So the next question I'd ask is, have we got an adequate test coverage? So I'd go and look at all our requirements and say, is every one of our requirements, is there a test for that? So again, coming back to our slug test, maybe we need to have something where if we have multiple spaces, they just get replaced with a single dash rather than lots of dashes. And maybe if we have things like an apostrophe, we don't report that at all. So I'd look at this and say, well, I can't see in my test case any of these, in my test suite, any of these tests. And these are things that should be covered off in the spec. So at this point, I would just raise them as a code review comment and saying, I think we've got inadequate testing. Here are the tests that I think you're missing. Now, it could be that the code is working and all these things are covered off. Or maybe it isn't. But either way, I wouldn't know as a code reviewer whether I found a genuine bug or whether I'm just raising an issue that needs to be looked at. So also, when you're looking at code, you can kind of have a look at it and work out roughly how many tests or the minimum number of tests are required. So if we were going to unit test this, quiz time now, what's the minimum number of unit tests we probably need for something like this? Any numbers at all? Yep. Sorry, 4? 4? Yep. Any advances on 4? I would say, looking at this, we need definitely 3, and we might need more. We can see that is allowed, it returns a Boolean. So we need to do something. We need a test where it returns true, and a test where it returns false. And also, if I look at the doc block, I can see that it throws an exception. So I'd need to do something that made that exception get thrown. So I'd say we definitely need 3 tests, but if I had more context about what's going on, probably I'd need a lot more than that as well. So again, if I'm looking at the code under test, I can then ask myself, have we really tested this adequately? And if we hadn't, I could say, I think we also need tests for this. So I think that's the most important thing we as human reviewers can do, is to check that our tests are correct, or we're testing the right thing. Probably the next most important thing is, will I understand this code in 6 months' time? When you're writing code, I don't know, I'm kind of in the zone, I understand what I'm doing. It all makes perfect sense to me. I then come back to it 6 months later, or a month later, or even a day later, and suddenly it doesn't mean anything. And the great thing about having code review is someone can kind of look at it who isn't, in your headspace, and they can say, well, that might make sense to you, Dave, but I have no idea what it means. So let's rewrite this, or let's make it clearer, or is there a way we can make that code more understandable? Because if it's understandable to someone else, it will definitely be understandable to you again when you next look at it. And your homework for this evening or next time is go and find some code you haven't looked at for at least 6 months and see how much of it you really understand. And again, this is important because from a business perspective, because we spend a lot more time reading code than writing it. So therefore, the easier it is to read the code, the quicker we are going to be to write the code. And again, just having someone else there looking at it, they can tell you if it's easy code to read or not. So here's some real code that I saw in code review. Anyone have any idea what this code is doing? I had to look at it. Sorry? What it's actually doing is it's taking data from user details and copying it to a user object. I had to look at this several times before I understood it. This is actually doing the same thing. It's saying if user details username is set, then I'll copy the user details into the user's username thing. So this code is a lot less interesting. There's nothing clever. It's quite boring. But generally, boring code is good. So if you see code that you really don't understand, unless there's a really good reason for it to be really clever, I would just say, look, we'll never understand this again in the future. So I'd far rather have this kind of boring code than the clever stuff we had on the previous screen. So the next bit of code, we had a class called location, and we could see from the comments that it represented a city, in this case in the UK, a city or town or village in the UK. And we had this method on it called getURL. What is the URL of a city or a town? I don't know. So, and I looked at the doc block and it didn't help me either. And the thing about this is it doesn't take much just to write a little line and say, oh, this is the thing, if you look at this is a link to its Wikipedia page or whatever it is. I mean, maybe we could give it a better name, but often it just takes a minute or two to write a good comment and then it aids understanding. I mean, another kind of code that you often see in code review, and this is the kind of thing that's hard to automate testing for, but in this case, what does number 1 mean? Again, we could use a constant or something like that. And then we have code which we might, on the face of it, thinks quite obvious. We've got this class called marketing campaign, and we're adding an address. But what does address mean? Is it a postal address? Is it an email address? Is it something else? So if I saw this in code review, I'd say, well, look, why don't we rename this to add email address so it's really obvious what we're doing? We could change the parameter name to email address. We could put a comment in it. We could start adding type hints, and maybe instead of having string for email address, we could have a value object. So these are the kind of things that is very difficult to automate and in an automatic way look at and correct. But it's the kind of thing that humans can look at it and go, I don't really understand that, or that's not as clear as it can be. So another question is, are we following project conventions? And I'm not so much talking about things that can be, are we following PSR2 or whatever, that should all be automated. But it might be things like this. So if I show you this interface, are there any method names that kind of jump out at you as odd? So they're all called find, apart from this one, which is called search. And is there a reason that it's different, or should that all have been called, should that really be called find by location? And it's things like this. What you need is to have whatever your project standards are, and then make sure they're enforced. And often you find when you start adding code review into your process, certainly when you first introduce it, you get a lot of discussions, because previously you hadn't really had that level of conversation about how we do things, what conventions we're following and stuff like that. So I'd recommend, I mean, I used a Slack channel, but you can use Google Docs, you can use whatever. And what we did when we started introducing code review to projects is we would say, look, here is a rule that we're all going to abide by. We're going to have do not use abbreviations in names, for example. And then in thread, we discuss why we come to that point. So if anybody needs to go back later and say, why have we got this rule, they can see the arguments for and against. And eventually you build up a lot of this and you can move it into an actual document for coding standards. But when you first start introducing code review, especially if you've not had it before, these are the kind of things that will come up time and time again, and you want to have somewhere where you can collate all this before they become firm standards. Another really important question to ask in code review is, are the comments still in line with what's going on in the code? So when we first write code, often the comments are correct. But as we start editing things, like methods and classes and what they do, sometimes the comments can become out of date, and then that's when they become useless. So as part of your code review, you want to make sure that actually everything is still aligned. Things like, has defensive coding been used? So we've got this method here called setStatus, and we can see in the doc block that we're saying status has to be one of started, finished, or quit. But there's no check for that. So if I saw this in code review, I'd say let's add an assertion in here to make sure that the status we pass in really is one of those 3 values. Oops. And then there's this naming generally. So often on projects, whatever domain you're working in, I'd advise, if you don't already have one, to have a document that states very explicitly the names of things. So one project I'm working on, we have these concepts of retailers and internal retailers, and they mean very different things. And what I would do when I'm reviewing code is I'd say, I'm looking at this and say, are we using the right terminology here? And again, this is something that we can only do as humans. And if things were being misused, I'd say, I don't think we should call it, like, instead of internal retailer, sometimes we call it manufacturer's retailer or test retailer. So, we're going to have one name for this, and we always refer to it in that way, both in code and in the comments. And the other thing is, like, design patterns. If we are, for example, have something that follows the design pattern, the factory, let's make sure we call it a factory. And conversely, if we had something that was a person factory and it didn't produce person objects, then maybe that's misnamed as well. So, and this is the other thing where you get, this is the great thing about code review, when you've got like varying degrees of experience on a team. Some team members may not have heard of design patterns, or they might not have heard a particular design pattern. So when you see some code, you say, actually that's really a factory, let's rename it. That person has now learnt the correct terminology for things. Naming is difficult, so it's really important to pick up on things that are not named correctly. A potentially controversial one is, has technical debt been documented? So there are times when we actually deliberately add in hacky code, and there's good business reasons for it. So a real example, last year, we had some code, and if we could release it before November, we had the whole Christmas window of November, December, where we could get a lot of money for the business. If we'd waited till it was like correct at a level, you know, coder would be happy with, we probably wouldn't release it till the middle of December or even January, and we would lose so many sales, it just wouldn't be worth it. So introducing the hack and retrospectively fixing it, and all the costs associated, occasionally something would go wrong and we'd have to refund people, but that cost was still a lot smaller than the sales we get if we release the code early. But it's really important that when we do put hacks in our code, we actually document them. So we have to-do comments for every hack, and we link it back. We use Trello, but it's whatever ticketing system you have. And that's useful in code review because then it alerts someone to say, yeah, I've actively taken a decision to introduce a hack here. And I've documented it. And it means because it's all in a ticketing system somewhere, the business has a good idea of how much technical debt we have in the system. Other things I'd be looking for is, overall, is the architecture okay? Are we using things at the right level of abstraction? And I'd use things like Solid to be your example there. And finally, do check, you might even find bugs. So here's kind of a checklist of all the things that I'm kind of looking for when I'm doing code review. And I'd recommend having similar checklists for your teams as well. I'll make the slides available as well on my website at the end. There's a few more photos. Right, and if we just want, basically a shorter list is like, make sure the tests are correct, make sure the code is clean, and make sure there aren't any bugs. Okay, so I've been doing this for a while, so let's look at some of the tips I've kind of picked up on the way. First question, who should do code review? I think everyone should do code review, not just like the tech leads. Everyone should be involved. What we've generally done on smaller teams is say it just needs one other person to review it. But if they're reviewing the code and they say, this is actually quite complicated, or I'm not happy to sign it off myself, they might say, well, I'm happy with this, but I want someone else to look at it as well. But I would get everyone involved in code review, because the learning is both ways, for the reviewer and the person doing the code review. Other thing is we want to keep our code as small as possible. If you ask someone to review a small bit of code, generally they'll find lots of errors. But if you ask them to review a lot of code, they'll just go, yeah, that's absolutely fine. So if you have some dodgy code, just put it in a massive commit and they'll never find it. So ideally, we just have really small feature requests all the way, and it's dead easy to review. But often that's just not possible. Sometimes the whole PR might be 1,000 lines of code. But what we need to do there is we need to then break that out into really small commits. And what I kind of say is let the commits tell a story. So maybe the first thing we're going to do is we're going to deprecate some old code. So we're just going to go in and mark all the stuff we want to deprecate with the @deprecate function. Then basically we're going to add a facade or whatever to use whatever our new price calculation service is. Then we're going to switch over from using our old price calculator to the new price calculator. And once we've done that, finally we're going to remove all of our deprecated code. And so what could be quite a big section of work has been divided down into 4 separate commits, and each of the commit is focused on just a very specific task, so it makes it a lot easier to review. And things like interactive rebase, if you're using Git, are great to help you out and make your commits nice and clean. How much should we do in one go? Not much. I'd limit code review to an hour. An hour of code review, you really kind of start to lose your concentration. So SmartBear did a survey of code review done at Cisco, and these kind of were their findings. Certainly no more than 400 lines of code at a time, under 500 lines of code per hour, and maximum 1 hour at a time. And again, if you go back to your commits and make them small, you can just do them in chunks. So even if you've got a PR that might be 20 or 30 commits, you just go and do them in small chunks. So what makes a good commit? Well, they want to be small and focusing on one thing, just like everything in software. If you're only making white space changes, do that in its own commit. So you've just got one thing that's a load of white space changes and no actual changes to code. You shouldn't really need to do that once you've got your coding standards tools in place. Make sure that the things, if you're doing something that's specific to a task or a Trello card, have a link to it in the commit message so you know what's going on. So you've done all that. What makes good comments? Well, don't be rude, basically. If you see something that you don't like, don't criticize the author. Just say something about the code. Don't say you're silly for doing that. Just say, according to our coding standards, it would be better if you did it this way. So it's non-confrontational. State the problem and a solution. So I really don't like it when people say that's a really bad name. Probably the author knows it's a bad name. They just can't think of a better name. So say, I don't like this name. Have you thought about this name? And then maybe they'd have to think about it. Go, oh, actually, I thought of an even better name. So try and offer solutions. Also, if it's quite a big thing, then probably somebody's already written a Stack Overflow post about it. So you say, look, I think this is wrong. See the Stack Overflow or blog or something like that. A thing I often use is this single let's chat. So if I think it's going to be quite a lot to write down, maybe it's just easier to talk face-to-face or on Skype. So we'll just say let's chat, and then that's an indication we need to talk about this further, but I'm not going to write it all down. Often I also use this thing called question, and the implication there is I think everything's right, but there's a gap in my understanding. So I'm pretty sure what you've done is correct, but can you just explain why you've done it in that way? This new Ansible thing that I don't understand, I'm pretty sure you're right, but I just want to know about it, so I've learned something. And if somebody finds a really hard bug, do compliment them. Every so often they go, well, that's great that you found that, so, be nice. And receiving comments is often pretty similar, like, don't be rude. They might have said something you disagree with, there's no need to be rude back. Try not to take offense. If the comment just says dot block, you could interpret that as, oh, they're nagging me about the dot block, or you could just say, I hadn't put a dot block in, they're right. Just because someone's made a review comment doesn't mean you're wrong and they're right. So if you do disagree, then have a chat about it, and probably by the end of that conversation, you'll both have a better understanding of whatever you're doing. And again, if they've done something well, compliment them. So our kind of overall code review tips: get everyone involved, make sure we keep the commits as small as possible, be constructive, and make sure you link to all the relevant cards, because that makes everything really a lot easier. Okay, so we've got about 5 minutes left. I'm just going to wrap up just to say how easy it is to actually integrate this into your project workflow. So I'm going to talk about GitHub, but other tools are available, and they'll be just as easy, really, to set up. So I'm saying that code can only be deployed if the continuous integration passes and code review passes. So assuming we have all our code in GitHub, we can turn on code reviews really, really quickly. So the first step is you go into settings for whatever your project is up the top. You then go to branches, and then you kind of do this thing saying we want to choose a branch to be the protected branch. So normally it's our master branch. And you can switch it on, and you say, I'm going to protect this branch. And that means all the things you've ticked are now requirements before that branch can get merged back in as a feature request, as a pull request. So we can say we're going to protect our branch, and we can require, just by ticking this, probably a bit hard to see, but download the slides, but we can say we cannot merge this pull request in until someone has reviewed it and signed it off as OK. We can do things like say, if it was all signed off as OK, and then I've subsequently pushed some new code, then I have to disregard all the previous checks. So somebody has to go and check all the new stuff you've pushed up. make sure that the branch is up to date before you merge in. So if you've merged off master and someone else has done some work, you need to make sure you've got all that work in before you merge your stuff back into master. And also, if you've got CI, then you'll say, I also require all my continuous integrations to pass, and you just tick the ones that you want. And once you've done all that, essentially, it's basically set up and ready to go. And then you make you instead of pushing straight to master, you put everything onto a feature branch, you make that a pull request, and then you can only merge that code back into master once it's all been signed off. And because it's so easy to use on GitHub, it's equally as easy to do on Bitbucket, and there are other tools. It's not difficult anymore these days. I used to use a tool called Gerrit, and that took like about a day and a half to set up. Now it's much, much easier. So there's no excuse to not really use these things today. So we've covered quite a bit. Essentially, the cost-benefit of analysis of doing code reviews is it finds bugs sooner. It removes them from those expensive time, hopefully down to time when you're writing code or at design stage. Most of the issues you'll find in code review will not actually be bugs, like the things that stop the code from working correctly. There'll be these evolvability defects, technical debt. But that technical debt costs the business money. That's why it's important. Code review helps us to spread the knowledge, so we're not working in silos. We've got an increased bus factor. People can go on holiday without having to worry about code and come back refreshed, ready to go again. It is really, really great for mentoring. I've seen people come up so much quicker in their ability because they're learning so much quicker off other people through the code review process. And just adding it in there, it means that you just change just the fact that code review's on and people all believe that my peer's going to look at what I'm doing makes a massive difference, a massive jump in the code quality. Of course, we want to automate everything we possibly can to minimize what humans are required to do because computer time is cheap. Essentially, the kind of things we're looking at are security problems. Are the tests correct? Have we got clean code? And are there any bugs? Those are kind of our main checklist of things we're looking for when we're manually reviewing code. Don't forget, when you start to have some kind of repository to discuss coding standards, so conversations are remembered, make sure everyone's involved. And if you do all that, then I think that effective code review will reduce the overall cost of software development. Thanks for listening.
Thanks for the pitch, and I have two questions. First, how much time is justified to spend on code review if 10 hours were spent to write the code? What is the percentage ratio is close to optimal, as you think?
So I would think if we're talking a day of code, so 10 hours more than a day. Well, in the UK it's more than a day, 10 hours. You probably work harder here. But I would think 10 hours of 10 hours of writing would be between half an hour to an hour of code review. But it sort of depends on the complexity of what's been done. And to a certain extent, it depends on how much the person doing the code review is aware of what's going on. So if you've got two people who are working on a bit of the code and they're both quite engaged in that, then the review time tends to go down. But if I'm coming in cold to someone else's code, then I've got to then start reading the Trello tickets or the story to understand. So that will be a bit more. But I would say 10 hours is probably between half an hour and an hour of code review. Probably towards half an hour. Yeah.
Okay, thanks. And second question is it good practice to check code also in the IDE, not only at GitHub? Because in IDE you see different and connections between part of code and see more.
Yeah, that's a really good point. Currently, I do most of my review in GitHub. I think, though, doing it in IDE is better because you can jump between things and stuff like that. There is probably a PHP Storm GitHub integration that will do these things. One of my colleagues uses Git cracking, and that allows you to, it's not as powerful as the IDE, but it allows you to do everything kind of more locally, and you've got quicker movement.
Kraken, is this something too?
Git cracking. It's I'll find a link and tweet it around. It's not as good as an IDE, but he swears by it. But I think you're absolutely right. Doing it in an IDE, if you've got that integration point, is good. The only issue is obviously if you're in the middle of work, then you kind of stash your work and move over. But also simple reviews, you're just as quick in GitHub.
Okay, thank you.
Thank you for your talk. What about, you told everyone should do code review. Yeah. What about junior developers reviewing senior developer code?
So, there's a lot of benefit in junior developers reviewing senior developers' code because they will learn a lot from it. But what they might do is potentially you might say, I want the junior developers to get used to the process of reviewing code. But maybe in the case where they're quite junior, you say, I want you to review it, but I'm going to have someone else review it as well. But if you don't get them engaged in the process from the start, there's no ability for them to learn, because they will learn from seeing code and seeing how things are done. Especially if you kind of suppose you're doing a feature and you break it down into lots of steps. That's a really powerful thing for someone to see when they're just starting, like how do we go around doing this? So even if the junior developer may not necessarily find any issues, they will learn a lot from doing that. But then equally, if they're not going to find issues, you'll have to get someone else to check it. So, but I would get them involved, yeah. Are you happy with that?
Yeah, well, juniors will not understand some piece of code, and you don't want senior developer to go down in code level for junior developer to understand it.
Well, there is a benefit. There's a massive benefit in upskilling your junior developers as quickly as possible, because then they won't be junior developers for long. Where I work with someone of a similar level of experience to me, and we do look at each other's code, every line of code. So I don't think there's a reason that senior developers shouldn't look at the details of the code. So I think it is perfectly acceptable for senior developers to look at the lines of code.
Thank you. And let's assume that there is some big part of application, and developers spend a lot of time to get into that field, a lot of details, and he's the only one right now who understands it. And then you bring other developer who will do code review, and he just don't know the sphere, the field.
Sure. Well, at least involving the other developer in the code review means there's some start of knowledge transfer. If you don't involve anyone else, then that person, that bit of code will be very much siloed, because if no one even starts looking at that code, then there'll never be any knowledge transfer. And also, if somebody suddenly knows that their code is going to start getting looked at, that quality, I assure you, will jump. Because it doesn't matter how good people are, when they know people are looking at their code, any professional will go, well, I'm going to make sure it's even better now because someone's going to look at it. So you're always going to have this issue. If you have a bit of code base that only one person understands, unless the code gets decommissioned, there will be a pain point where somebody else has to get knowledge of it. And it's probably far better that it's done on a gradual basis. Sure, someone may not find all the issues with it, but they're slowly building up their knowledge, and the other team are building up their knowledge of this bit of code that's a problem. So I completely agree that they might not find everything because they don't have the understanding of it, but I still believe that should be looked at.
Great. Thank you.
Thank you for speech. It was very interesting. I have a bit tricky question. For example, we have a big team with different levels, junior, senior, mid, and we have situation when the code review doing randomly. For example, you doing a feature and someone randomly gets the code review. How find out was that code review effective? And who should do it? Finding out is a code review are effective.
Sorry, so as in when should the code review get done, and how do we know if it's effective? Are those the questions?
One more time, please.
Sorry, so can you just repeat the question again, please?
The question is how find out was the code review effective? Good enough to, and who should check was code review effective?
That's a good question. So I would assume that if it is a senior developer reviewing another person's code, I just assume that that code review is effective because they're senior developers, they should know this. If you have got more junior developers, then I'm kind of assuming that there's a level of professionalism there, that they would say, this is a relatively simple review, I'm happy to sign that off. But I'm also thinking if they're relatively junior developers and they look at this and they say, I haven't found anything, but I don't fully understand it, so I want someone else to look at that, then I would expect to have an environment, you want to foster an environment where people can say that, so they can say, look, I'm new to this project, I can't see any issues, but I want someone else to have a look at it. So, so essentially, your question is, how do we know if it's effective? I'm assuming that people are just, the senior developers are effective, and the junior developers will say when they need help on this. But there's actually no way. I mean, it's a really good point. How do we know? I don't often retrospectively then look at code reviews to see if they found everything. But that's potentially, if you're struggling, if your team is struggling with code reviews, then maybe the tech architect or the tech lead could then go back and look at some of the reviews to see if everything was found. And then they could also go back and say, all right, you didn't find this, here's some guidance to help you find these kind of issues in future. But if you have a checklist that will help focus the mind, but again, if you have people who are not as experienced, like the previous question, if you have someone that just doesn't know that bit of code, then they will not be as effective as someone who does, but at least you're moving in that right direction. So not all code reviews will be 100% effective, but I believe they are better than not having them at all. But it's a really good idea, actually on occasion reviewing them. Maybe like at the end of a sprint, you can pick out 3 or 4 big code reviews and just review them, everyone in the room, to say, did we find everything? That's a good idea.
Did I get right? It's a good idea sometimes to do a code review with whole team?
I personally don't do it for the whole team on a regular basis. I suspect what really happens is that when we have points that we need to discuss. So at the moment, for the last 3 years, I've been working with senior people, so it's quite a nice situation. But remember when I said we had that coding standard Slack channel? Often what happens is, as a result of the review, I'll have a question saying, what are we going to do about things like this? And then we have a discussion. So it might be based on a particular bit of code we're reviewing, but then it becomes a more general discussion point, like, this is how we're going to do something project-wide or even, company-wide. So it's not all of us sitting down and having a look at a whole, because a lot of code review is quite mundane. It's just okay, like, they've done that right, they've done that, or they missed something here. There are bits when it's quite a big question, but the other thing is you kind of want to avoid the big questions at code review time. You kind of want to push them forward to architecture discussions before you start doing your coding anyway. So the answer to your question is, rarely would I sit the whole team down, but actually there are times when we take an interesting element of code review and discuss it as a team.
I get it. Thank you.
Thank you for your speech. I think you know about the method of programming in pair, I think, yeah? When two programmers write code,
Yeah.
well, actually only one is writing,
Yeah.
and they change every 20 minutes, I think. I asked because this is a kind of code review.
Yes, absolutely.
Of course, the time spent for writing code is much long, but the bug can be find it and fix it exactly when the bug is written, yeah?
Yeah, yeah.
Not after 2 or 3 hours.
Sure.
So the question is, what do you think about it, and did you try it?
So I've not done enough pair programming to know if it's more or less effective than what we do currently. If I was doing pair programming, then I would assume that the code is fine. I wouldn't do any extra checks on it after pushing it up. So I'd miss out all those kind of steps that I kind of discussed, but we'd be looking for those things. So pair programming, there's a few reasons why you might not want to. I'm not knocking pair programming at all, but there are a few practical reasons why it might not be possible. So for example, on a project I'm currently working on, we need to give the client continuous support, but they can only really afford one person per day. So there's never a time where both of us are in the room at the same time. So pair programming is just not possible. So we have to resort to this kind of review process. And as to whether pair programming is better than this, I'm afraid I'm not qualified to say because I've not done enough pair programming to answer that question. I'm sorry. Yeah. I mean, I have a question. So I'm basically here on Monday. Has anyone got any recommendations for things to do? Just tweet me, DMs are open, of things to do in your beautiful, beautiful city. Right. And there's the references. Right, I've got to pick a prize, have I now? What do I need to do now? I need to pick the best question, do I? But they were all amazing questions. But that chap over there, he mentioned something I'd not had asked as a question before about do you review the review process? So I think that was a really good question. Yeah. But they were all great questions, and it's so many more questions than we normally get. So yeah, thank you.